Hello again. As we begin today, there's something I need to make particular mention of. I've tried to figure out how to do this so that you can actually have everything you need, and it's kind of hard to do it on a whiteboard. So let me just suggest before we begin that you go to the notes and get a copy of the problem-solving strategy. We're going to be talking about problem-solving today, and there's a strategy written there, and it's kind of hard to, I can go through it and tell you the steps, but I don't think you would remember if I just told you the steps, and you're going to want to have those steps to refer to as we talk about how to do this. So it's going to be important for you to go to the notes and get that information so that this will work a little better for you. Before we begin, I want to just do a quick review on what we talked about before in terms of solving equations. We talked about, basically the things we do. I called it the principle of balance because I wanted to get you to kind of visualizing that, as with any situation where you have things in balance, if they're in balance and you want to keep them in balance, we use the example of a teeter-totter, for example, or maybe chemistry in a chemistry lab, the balance way, the balance. Can't think of the word I want to use. Anyway, so to keep it in balance, if you do something here, you got to do exactly the same thing there. You might remember that idea. We talked about the idea that addition and subtraction undo each other, multiplication and division undo each other, and then there was a process that we followed. And basically what we were doing was undoing everything but the variable, so that in the end we had the variable by itself on one side of the equation. And so that meant we were using x equals something. By the way, I think this video may take a while, so I would suggest that you make sure you've got a little extra time to do this, because I don't want to rush through. This is such an important and critical area in math, and one that so very many people have difficulty with. So make sure you've got enough time so we won't have to rush through this and not be able to give you time to digest the ideas we're going to be talking about. We're going to do, for review, we're going to do a problem. The reason we need to do this is because we are talking about problem solving, and when we solve a problem, we're going to be solving equations to find information that we need. So here's our example. I've got 4x plus 3, 4 times x plus 3, and minus 2x is equal to x plus 16. Okay, this is the equation that we're going to solve as for review. The first thing we checked on was to make sure we understood that when we talked about solving equations, we want to have our variable, in this case x, by itself on one side of the equation. And then we're going to do whatever we have to do to undo all of that stuff except 1x on one side of the equation. So basically that's the idea. Now let's go ahead and do it. The first thing we had to do was eliminate parentheses. So I look up here, and sure enough there's a set of parentheses, so I'm going to eliminate them. Well, I know that this means, when I look at it, 4 times that group that's inside the parentheses. So I've got 4 times the x plus 4 times the 3, and so then it looked like this. The next thing we did, and these first two steps are basically just steps for simplifying, so the next thing we did is we combined the like terms, and 4x and 2x are alike. We're going to combine them by doing what it says we're supposed to do. So we got 4x subtract 2x. So that gave us 2x. The next thing we needed to do is check to see if there are variable terms on both sides, and there are. So we have to get rid of one of them. There isn't anything that says which one, but in this case, we're probably going to want to get rid of this one, because if we get rid of the smaller one, do what we have to, we aren't going to have to deal with negatives. Sign there, whenever there's not a sign written, it's understood to be positive, so that's like plus x. We remember subtraction undoes addition, so we're going to subtract an x. Now sure enough, x subtract x is gone, so they cancel each other out, which is what we wanted. Over here, we're going to have 3x plus 12 is going to be equal to 6. Didn't allow myself enough room here, so. Okay, the next thing we did was any addition or subtraction we needed to. And since addition and subtraction are the ones that undo each other, I just look for addition or subtraction. So here's a plus, so we're going to subtract the 12. We have to do it from both sides to keep things in balance. Those cancel, and they always will. That's the thing. If we do what we're supposed to, they do undo each other, and they're gone. So that leaves us with 3x equals, and then I come over here, 6, subtract 12, and you visualize now, here we are at 6, we're subtracting 12, going to leave us at minus 6. Last thing we do is divide by 3, because this is multiplication. 3x means 3 times x, so we undo that by dividing, and our answer then becomes x equals negative 2. We can check that to make sure it works by putting it back up here in place of this x up here, all of the x's up there, and see if it works, and so that's how we do it. Now that was just to review what we did, because we are going to be talking about solving equations when we do problem solving. So let me quick here erase. I don't know how well you can see it. I wasn't sure how to do it, but I tried to put the steps up here for problem solving to see if it would help at all. That's why I'm suggesting really that you go to the notes on the site and get the copy of those where you can look at them and look at them up close. Now, problem solving is something that's very, very valuable. You know, some people learn how to do things without what we're going to talk about here, but if you know how to do it, it really gives you an advantage in a world where a lot of people don't. They don't know how to solve these kind of problems. And quite frankly, problem solving is problem solving. I don't care whether you're talking about math or whether you have to make a decision or do something in your everyday life. The process for solving equations is basically the same as it is. So once you learn this skill, not only will it help you in anything to do with math, but it's also going to help you to deal with problem solving in any situation that you might be faced with. So keep that in mind, because sometimes we need some motivation to help us understand why are we going to do this? Why do I want to do this? It is something that's very valuable. Okay, I'm just going to quickly run through the steps, and if you've got them there, you can look at them as you go through. The first thing, and this is true about any problem that you want to solve, you got to know what your aim is, what your goal is, what you're trying to accomplish. So when you get a story problem, the first thing you do is read through carefully, but all you look for is that place somewhere in the problem where it says, do this, find that, what's this? It asks you a question about what you're supposed to do. Second thing you do is you choose an appropriate variable, because in math, when we're solving problems, we're looking for numbers that represent something. And since we don't know what those numbers are, we know that's where we use variables. So we're going to pick, you could use anything you want, but sometimes it's helpful to pick a variable where you know You can tell by looking at the variable. It will help you remember what it is you're looking for. And something that's really, really important. It's a difficult thing to get people to do, but it's very, very important, and that is when you pick your variable, you write down a very meaningful description of what that variable represents. You need to help your brain be able to have something to look at it and know exactly what that means. It will help you as you read through the problem. When you come across that description, you know you can use that variable to replace all those words. And what we're doing when we do problem solving is we're translating words into mathematical symbols and terms that we can use to solve the problem. So you want to be able to do that. Okay, if you can, and now of course this won't apply to most, but probably most people that would be looking at a tutoring video, if you can, you want to draw a visual representation of what's happening in the problem. Most people are visual learners, and that means simply if we can see, visualize what we're looking for, it makes it easier for our brain to understand what it's supposed to do. So if we can, we draw a picture. The next step is, after you've completed the first three steps, not until, but after you've completed those first three steps, then you go back to the beginning of the problem and you start reading it over. Only this time you just read until you come to anything related to the problem. When you come, you stop and write down something to represent what you just read. And you'll see how this works. It's not that complicated, and in fact this is one of the keys to the secret. I've said this over and over again. One step at a time, it will be fine. And basically this whole plan is intended to get us to where that's all we're doing. We're just looking at one thing at a time in order to keep ourselves focused on one thing, because usually we can deal with one thing. It's when it gets more than that we have the problem. Now, a lot of the times when we're reading through the information we have and applying what we know about the vocabulary, we put all this stuff down, suddenly we're going to have an equation. Now, if that happens, that's wonderful, because now we're ready to go. We solve the equation. If it doesn't happen, then we may have to come up with some idea or formula that ties all of the ideas that we end up writing on the board together, and then that's usually indicated by some kind of a formula. Again, we will have our formula or our equation. The formula will give us the equation, so we will be able to just then focus on solving the equation. And that's the next step. And it's a challenging one, but it's so important. Once you get your equation, just put the problem aside for a second. You know you've got your equation. You know the equation is going to give you your answer. So you just focus on solving the equation. And that, of course, that makes it easier for you to remember the steps for solving equations, because our brains don't do too well when we're trying to do two things at a time. And I want you to know that this process that I have here, I developed this because I can remember when I first graduated from college and I was teaching high school, and I remember when we used to come to problem solving, it scared me to death. I was afraid some student would ask a question and I wouldn't be able to answer it. That's not very impressive when you're the teacher. So I felt like it was important to figure out why, because I knew I could do it. I just, for some reason, it just overwhelmed me. And that was the problem. It was overwhelming, literally. When I would look at the story problem, all that information was just coming at me so much that I literally would go into overload, and then I couldn't focus on what I needed to do enough to get it done. So this process was intended strictly to make sure I was just looking at one thing at a time. Now, the notes have the vocabulary words that you can look at. If you've got them, you've recognized that. So that will help as we go through the problems. You'll see how that works. Now, once we've got the equation solved, the next step is to see if the answer we got fits what we were looking for. If it does, if it makes sense at all, then we take the answer that we got and check it against the requirements to make sure that we didn't find that what we found is in fact the solution. And remember, solution is what works, and that's true no matter what you're talking about. The solution is what works. So let's go through some problems here. Now, you aren't going to be able to read these, so you're going to have to listen carefully, but that's good practice, because if you can listen and follow this process, then you can certainly read and follow the process. So you listen carefully, and remember, first and foremost, what are we looking for? So as we go through these problems, and I'm going to start out with some really simple ones. We won't go through and solve all of the equations that we get. Maybe you will do one for practice. But mostly we're going to do this for practice until we find out what our equation needs to be. So, number one, here's our problem. Now you listen carefully, and remember, first time through, you're only interested in what we're looking for. So here's the problem. The sum of a number and 3 is 10. Now, did you feel a need to start writing? You want to put stuff down? That's normal. That's what our brains want to do. And that's why I had the problem and why I developed this. But I only look for what I'm looking for. So then I go on. The sum of a number and 3 is 10. Find the number. So that's what I'm looking for here, is a number. So I'm going to pick a variable, and you can use anything you want. You might want like x. People seem to like x really well, but maybe you like n to help you remember that you're looking for a number. And that's what you write here. You write it out so that you can see, your brain can see right there. Whenever you hear the word number, that's what it's equal to, n. And if you see an n, you know that's the number. So that's got to be clear in our brains. Okay, so we could draw a picture. You can draw a picture of anything, but if it isn't going to help, we don't want to waste time here. So drawing a picture is not going to help. So now we're ready to go back, start again. And watch how this works. We read until we come to something. So the first thing I see is the sum. Well, what does that tell me? Okay, I'm going to be adding, but I'm going to write that down. That's the symbol that means sum, so I'm going to write it there. I don't care how it fits in right now, I'm just going to write it there. The sum of a number. Well, there's that word, a number. So I know I can put the n right there. A number and the sum of a number and 3. Okay? Now you take a look at that and see if your brain can say, oh yeah, that says a sum of a number and 3. Well, if I'm just looking at one thing at a time, I can get that. The next word I come to is, and I need to know, when I hear that word, that's where I write the equal sign. So now I've got the sum of a number and 3 is, and it is 10. So just taking those words and applying them here, I have an equation. So at this point in time, that's where I'm going to stop thinking about the problem, and I'm going to focus on solving that equation. I think we'll move on and pick one that's a little more challenging to actually solve the equation. But you get the idea? And think about it for a second. How hard was it to come up with this when we were doing just one thing at a time? Okay, so let's go on and try a different one, maybe a little more involved, to show you that it works anyway. Okay, so here's our next problem. Now you're going to be listening, And all you're going to listen for is when it tells me I'm supposed to do something. If 4 is added to the sum of twice a number and 3 times that number, the result is 34. Find a number. Okay. Did you get that? All that other stuff in there does not matter for us until we find that one question that tells us what we're supposed to do. We're looking for another number. Now, just to show you that you can use any other variable, I'll pick another variable this time. Let's say x is going to be the number. Now again, we can't draw a picture of this one, but we're not going to worry about that. But now we're ready to go back and start at the beginning, read through carefully, and find out information. So, 4 is added to. Now this is important. You got to think about how you do this. When you write this down, it's going to have to show that 4 is added. But when I do that, I want to do it this way. That tells me that the 4 is added to something. If I put 4 plus, then something is going to be added to the 4. So that's very important that you think carefully about what it says. Okay, now 4 is going to be added to the sum. Okay, so again, I've got a sum here. Now, if I've got to add it to the sum, think about it for a second. Doesn't that tell your brain that you have to get the sum first? Now, we have some things in math that help us with this idea of do this first. Remember from order of operations? Grouping symbols. And parentheses are the one we run into most often. So I'm going to put my parentheses in here because I know that I've got to find that sum first. Okay, 4 is added to the sum of twice a number. Well, how do we find twice the number? Well, if we know that our number is x, twice just means 2 times. So once I got that right up there where I can see it, then it's easy for me to write 2x in there. 4 is added to the sum of twice the number and 3 times the number. Well, 3 times the number is okay again as long as I'm thinking, well, my number is x. Whatever it is, that's what it is. So I got to multiply that by 3. And then it says the result is, okay, there's my equal sign again, and the result in this problem is 34. Okay, let's just quickly go through this one and solve the equation so we can see that we actually do this. Here I've got my equation, and now I'm going to forget about the problem for a second, and I'm going to solve the equation. First thing I do, of course I know I'm looking for my x down here, but we get rid of the parentheses. So sure enough, 2x plus 3x is 5x, and once I have the 5x, I don't need that parentheses anymore. So it looks like this. 5x plus 4 equals 34. There are no like terms, and remember, you've got to be, when you talk about like terms, you can only combine things on the same side of the equation, so I can't do anything anymore with this. There isn't anything to do. I look to see if I have variable terms on both sides. I don't, so I don't have to worry about that, and I'm perfectly happy when I don't have to worry about a step. Is there any addition or subtraction? Well, sure there is. There's a plus there, so I'm going to subtract the 4. To keep it in balance, I have to subtract it from both sides. That leaves me now, those will cancel, that leaves me with 5x equals 30. I have a multiplication here, and that's the next thing I do. Any multiplication or division I need to take care of. They're multiplied, I need to divide, and 30 30 divided by 5 is 6. Okay, I was looking for a number. Did I find the number? And then I can check it by putting that number in there. 2 times 6 is 12, plus 3 times 6 is 18. 18 and 12 is 30, plus 4 is 34. So yes, it works. And that's it. One step at a time, it'll be fine. Okay, now I want to just quickly do one more, and there's some other problems in the notes if you've seen, and you can practice with that. Just watch the video and then practice with this until you can kind of get comfortable about what to do. Okay, here's the next one. The length of a triangle is twice the width. If the perimeter is 42, find the length and the width. So what are we looking for? It said find the length and the width. Now, what would be appropriate variables to use for that? Well, L could be equal to length. W could be equal to width. Because when I see L, I think length. When I see W, I think width. Now, the next thing is, can I draw a picture? And yes, I can here, because this is a rectangle. I know what a rectangle looks like. So I draw the picture. And to make sure I know what I'm dealing with, I remember that the long side is length, L for length, L for long, and the short side is width. And maybe to be absolutely clear what I'm dealing with, I could remember that this is also a length and that's also width. Okay, so now I've got my picture. Now I'm ready to go back through the problem and see what it says. Okay, in a certain triangle, the length of the triangle is, let me write these down, the length is twice the width. Okay? That's what that says. Now, I'm not sure exactly how I'm going to use it just yet, but that's what it said, so I wrote it down. And as long as I'm doing that, I might as well put it up here on my picture so I can see. The next thing I come to in the problem, it says the perimeter is 42. Use P for perimeter is 42. And that's all the information they gave me. So I look at that and say, okay, there must be something here that I need to know so that I can finish this out. So I think about it and I say, oh, perimeter. Oh, yeah, right. That's the distance around the outside edge. So I'm going to, the perimeter is, and right there on my picture, I've got some information that's very helpful because I can see the rectangle. The perimeter is the distance around the outside edge, so if I add those sides up, I'm going to have the perimeter. Now, if you just have a W and an L there, and you write this out, it's going to look like this. W plus L plus W plus L. Well, that's all well and good, but you know what? We can't solve an equation that has two variables. And it's no reflection on you or anybody else, it's just we can't do it. Our rules for solving equations involve one equation, one variable. So if I'm remembering that when I write this, I look up here at my picture, what I see, I've got everything I need there. I could have done this. I got a W, and then instead of the L, I'm going to write two W's. And then I got this other W, and then I've got another 2W. If I didn't think about that, then I've got this little equation here that says, you know what, L and 2W are the same thing. So everywhere I have an L, I could write a 2W instead. They are the same thing. So I'm not changing anything by doing this. So I could go in here, and instead of writing that L there, I'd write the 2W. Instead of writing that L there, I'd write the 2W. Of course, if I have my diagram, and I can see it there, I can visualize it, I did exactly the same thing just by looking at it. And it doesn't matter which you do. You do what works for you. But anyway, then you have this equation. All right? So, go ahead. Now we're ready. We've got our equation because we got the idea of the formula. Now we're going to solve the equation. There aren't any parentheses, but there are some like terms. Every one of those is alike. So I've got 1 here, 2 here, 1 there, 2 there. Altogether I've got 6. So when I combine those, I get 6W is equal to 42. Well, now I've got a multiplication here that I got to undo, so I'm going to divide, and I get W is equal to 7. Now, sometimes people get so happy and giddy because they actually solved the story problem that they quit, ready to move on. But you need to look back up here, and you need to have written this down so you'll see it. I'm supposed to find length and width. And what I found was width. So I've got to find something that will help me to find the length. I look back through the stuff that I've written down here, and guess what I find? Right there. Oh, the length is twice the width. I take my width and I find twice that, which means 2 times, and I get my length is 14. That's what I was looking for, so I'm okay. But notice, if I hadn't gone back through and checked that, I might have forgotten and not did what I need to do. But I've got it. And if I want to check it to make sure if it works, if I add 7 plus 14 plus 7 plus 14, guess what I get? 42. So those are the numbers that I need. Now I know this is a little bit rushed. It's hard to do story problems. If this is something you need a little extra help with, of course you're welcome to get in touch with me and we can do some face-to-face on it. But practice with it, and remember, it's absolutely essential. One thing at a time, it will be fine. So, look forward to seeing you next time. Thanks for coming. Bye.